Hello, Tassos.
Hey, I'm here.
I'm sorry about that. Our IT team scheduled a different session with someone else, and this day's been quite crazy, so they didn't notice our webinar. I already talked to them. They're gonna move it to tomorrow, so we have all the time for today. So I don't know. Let me check. Everyone is back. Okay, so we're back to the webinar. We're sorry about that inconvenience. We're gonna continue the webinar until 10 or 11. So thank you so much for being here again. Tassos is gonna continue with the webinar, and we got plenty of time to cover any other issue or any subject that you guys want. So Tassos?
Yeah, if you can make me a presenter, then I will go ahead and set this up and get it going again.
Awesome. Right there.
Excellent. Nope, hold on a second. It's not letting me switch my screen. Hold on.
Oh, let me do that right now. I think this will help.
There we go. Yep. Thank you.
Okay.
Excellent. So you should see the TWISTPORT adapter for Microtech, correct? That's where we left off?
Yes, that's correct.
Excellent. Okay. 2 more seconds here, and I'll be ready to go. Okay, so great. Sorry about that. So as where we left off on the TWISTPORT adapters for Microtech. So the first adapter I believe you all saw was the TWISTPORT adapter plastic. Again, this is a plastic enclosure that allows you to put any of the 411, 711, 911, and the M11 series boards into the adapter and use them in our waveguide radios. The second adapter for ROUTERBOARD is our ROUTERBOARD cast. This is a full metal enclosure that gives you better EMI protection and is something probably better suited where you need or where you're operating in a more harsh environment. It has a full O-ring seal, and again, it's all metal enclosure. So again, this adapter works for all the same 911 type boards and M11 boards from Microtech. If you're using Ubiquiti, we have a bunch of adapters for the Ubiquiti radio system. So the first one is the TWISTPORT adapter for the ISOSTATION. So this is basically a waveguide converter. So this converts Ubiquiti's waveguide fed radio into our waveguide connector and allows you to utilize, again, their round form factor radios with any of our TWISTPORT enabled radio systems, our antenna systems. As far as compatibility goes, this one adapter works for the Ubiquiti ISOSTATION M5. This is their 802.11 round form factor radio. The ISOSTATION 5AC, which is their 802.11 AC radio system. Again, these two are the CPE versions of that radio. And then finally, the PRISM Station 5AC, which is the access point version of their round form factor radio with the filtering built in. So any of these 3 round form factor radios, this one adapter will allow you to use any of those with all of our TWISTPORT enabled antenna systems. If you're using the Rocket 5 Prism or the AirFiber 5X platform, this one adapter, the TWISTPORT adapter PAF, PAF stands for Prism AirFiber, again, will allow you to connect any of the Prism stations or the AirFibers with this one adapter into our TWISTPORT adapter. This adapter has another new, very unique feature, and that's the GPS antenna integration. So if you lift the cover off of it, you have a very nice and safe place to put the GPS puck for the PRISM and the air fiber radios. In a lot of installations and in a lot of different areas, birds and other things like to chew on the GPS cables when they're external. So this gives you a great place to hide it safely underneath the adapter, and therefore give you yet another great feature from RF Elements. As far as compatibility goes, again, this one adapter works now for the new LTU rocket. It works for the AirFiber 5X and the newer AirFiber 5X HD. It works for the original Rocket Prism 5AC and the Gen 2 Rocket 5AC. So again, one adapter for 5 different radio platforms. Now, specifically on the LTU rocket. So there was an issue with the rocket where the adapter, the slide-in piece, didn't fit. And there's a very simple fix. If you have our older ones, you simply need to cut just a little bit of the plastic out in these specific regions, and then it will fit perfectly onto the LTU rocket. All new PAF adapters should have this fix already built into it. So basically, if you have anything that's shipped before November of 2019, you'll have to do this simple little modification yourself. If it's shipped after that, you should start having it work straight out of the box. So very simple fix if you have these radio systems. If you're using some of the legacy Ubiquiti radios like the Rocket M5, we have a new updated adapter for that as well. So it's the RM5. These are, again, great radios that work very well with our horn antenna. So don't be worried if you have older radios. You don't need to upgrade necessarily to the newer radio platforms to enjoy the use of our horn antennas and other antennas. The same can be said for the Rocket 5 AC, also known as the Rocket 5 AC Lite. So if you have that first generation of AC radio from Ubiquiti, we have an adapter that works for that radio as well. So a huge collection of adapters for Ubiquiti and a lot of support there.
Hello, everyone.
Sorry, did you say something?
Yeah, I think if you could go back a little bit, I think your audio was not clear for the last 20 seconds.
Okay, so again, the last 2 radio platforms, I'll go back one more. So the Rocket M5 from Ubiquiti is also supported with our adapter. So if you have an older legacy radio system, you can use these adapters and still benefit from our antenna systems. And the same goes for the Rocket 5 AC. This is the first generation AC radio from Ubiquiti. It's also known as the Rocket 5 AC Lite. So if you're using that radio, again, we have an adapter that will allow you to use all of our TWISTPORT antennas for them. If you're using Mimosa networks, we have a few adapters for that as well. So the first adapter we have is for the C5C. So this is their first connectorized small radio that they made. This is basically a client radio or also capable for point-to-point. So if you're using the C5C from Mimosa, we have an adapter for it that again will allow you to use any of our radio systems. And then finally, our newest adapter for the C5X from Mimosa. So again, this is another waveguide converter that converts their waveguide interface into ours, so you can utilize that radio with any of our TWISTPORT antenna systems. Another unique feature of the C5X adapter is the ability to adjust this from H and V to slant 45. So you connect it in one direction and you could use it in H and V. And then if you put that slider in where the arrow points to slant, you're now able to use slant polarization with our TWISTPORT antennas. One thing to note is that this slant 45 functionality only works with our symmetrical antenna series and will not work very well with our asymmetrical. So this is really for the symmetrical series only if you want to use slant 45. Okay. And then finally, for all other 5 gigahertz radio systems out there, we have a connectorized TWISTPORT adapter with SMA connectors on there. So basically, if you're using a 5 gigahertz radio system where we do not have a specific TWISTPORT adapter for, this is the adapter you want to use. And typically, this is for larger form factor radio systems that are out there. Like, for example, if you're using the 450i from Cambium, or the A5C from Mimosa, or the PTP 550 from Cambium. So any, again, large radio where we don't have a TWISTPORT adapter, this will give you SMA connectors that you can connect LMR from your larger form factor radio or unsupported 5 gigahertz radio and still utilize all of our TWISTPORT enabled antennas. We also have a TWISTPORT adapter cheat sheet for you. It's on our website, so if you want to cross-reference or look back to which adapter you want to use, you can go on our website and it will show you every adapter we have and the specific radio platforms in which they support. So this should make it quite simple for you if we went through it too fast and see which adapters work for which radio system. So now we'll move on to the antenna portion of the presentation that completes all of the TWISTPORT adapter and compatibility questions that you may have, right? So the first antennas on our product map here will be the symmetrical horn antennas. Now these are the antennas that we offer with a symmetrical beam pattern, and we have everything from 30 to 90 degree symmetrical horns in 10-degree steps, so 30, 40, 50, 60, 70, 80, and 90 degrees wide. For those of you who haven't seen our product, this is what it looks like. Again, this is our symmetrical horn TWISTPORT series of antenna. So what makes the symmetrical horns unique, right? And basically, it's their symmetrical beam. So if you look at the azimuth and elevation cut, you can see that the beam is symmetrical in its shape. It's just as wide as it is tall, right? So that's why it's called a symmetrical beam. It's the shape of the beam that comes out of it. If we want to compare it to your traditional sector, here again, you can see the big difference between the two antennas. First, you'll notice that the beam shape is different. Again, the one on the right is symmetrical and the other one is asymmetrical, but you also notice absolutely zero side lobes, right? So this is the great thing about our antennas. If we look at a radiation simulation, right, from the antenna modelers, here you can see on the left is a 90-degree symmetrical horn, and you can see a very symmetrical beam pattern with no side lobes and very little to no back radiation, compared to your traditional patch array sector antenna, where you can see how it leaks a lot of energy out the back of the antenna and has a lot of side lobes that make it operate much wider than your it's much wider than the spec sheet of that antenna. Another very unique characteristic of our antenna is the null coverage, or the dead zone underneath the antenna. Because symmetrical horns have much taller elevation cuts, you can see that the dead zone underneath the tower itself is much smaller in comparison to a traditional sector. So you're able to cover your close-in clients and your further out clients without having to use massive amounts of down tilt or potentially multiple sectors in order to cover the same coverage area. Frequency stability is probably one of the best traits of our horn antennas outside of not having any side lobes. And it's really important that you understand with traditional antennas, as you sweep through the frequency range, the gain of the antenna changes and also the coverage pattern of the antenna changes. So here you can see as we sweep through the frequency range, the antenna pattern doesn't change much. And if you look at it in the two-dimensional form on the right, you can see how the coverage area is much more stable as we change frequencies. If we compare this to your traditional sector, your patch array sector, you can see how much the antenna pattern or the radiation pattern of the antenna changes as we sweep through the frequency range. So not only does the coverage area on the right in two dimensions change, but also the side lobes grow and change in complexity as well. This is probably the number one thing that affects WISPs. When you actually change frequencies and you have customers all of a sudden fall off that had good signal, and people tend to attribute that to noise on the new channel that you went to. But typically as a WISP, you don't go to a new channel if you see noise there. So the channel is probably clear, and what's happening is the coverage pattern is changing, and now you're not getting the same signal intensity throughout your coverage area because of the dynamic change and the instability that these sectors have as you change frequencies. So signal density is one of the ways in which we achieve this really great noise reduction, right? So how fast the signal falls off as you go to the edge of the coverage pattern for that specific antenna is really important. And you can see on the left, a horn antenna, the signal drops off by 3, 6, and even 12 dB, very close to the edge of that actual antenna pattern. If you look on the right of a traditional sector, the bleed off is much slower. So that means that your 90-degree sector is really more like possibly 180 degrees, because the signal drops off so low, it still has a very high intensity signal outside of that spec antenna pattern. So it's very, very important to note that as well. The symmetrical horn series of antennas, again, come in 7 different sizes, everything from 30 to 90 degrees in 10-degree steps. The important thing to notice here is the gain to beam angle relationship. So the more we focus the horn with, let's say, our 30-degree horn, you see it's 18.5 basically dBi of gain. If you look at the widest one we have in the symmetrical series, the 90-degree, you can see it's only 9.6 dBi of gain, right? So the wider you make it, the less focused it is, the less gain you have. And the reason it's important to understand this is because a lot of first-time users think, hey, I have a 90-degree sector, I'm just going to put up this 90-degree horn and expect the same difference. And you have to understand that this horn is anywhere from 8 to possibly 10 dBi less gain than the traditional sector that you just swapped out. So as long as you understand this relationship, you'll have a much better experience using the horn, because again, you need to know you can't compare a higher gain sector to a lower gain horn and expect the same results. Very compact size of our antenna makes it very unique as well. Our typical symmetrical horns are roughly about the quarter or a third of the size of your traditional sector. So what this means is that you can get anywhere from 3 to 4 times the AP density in the same vertical space of one traditional sector. So this is very important when you're trying to build high density networks, when you have towers that maybe don't support so much weight or can't hold up so much wind load. The symmetrical horn's compact size makes it a very unique and great feature for networks that might need to grow and scale up. So really the symmetrical horn series is a co-location miracle. It really is. If you look at your kind of, traditional setup with patch array sectors with tons of side lobes on the right, you can see how all those side lobes and how the antennas, when they're much wider than they need to be, create this region of noise and contention between the access points, and makes it very difficult for them to operate without interfering with each other, which, in essence, creates lower network throughput, because again, it's spending more time dealing with noise than it is passing traffic. If you look on the left, with symmetrical horns, with their extremely precise beam angle, their very high density signal, right? You can see how you can co-locate many more access points on the same tower and on other towers, and therefore increase your aggregate network throughput from that actual transmitting station. And this, co-location miracle is not just something you see on a spec sheet, right? It's really not just something that is marketing fluff and we're just saying, hey, it works. This here are pictures of basically the standard of installs today, right? So you can see how you can co-locate tons of these horns on the same tower. You can co-locate them on the same mast, and you could really get this high density or massive scalability that we've been talking about for years now. So again, the use of all of our horns, not just the one type, but all of our horns together allow you to build very dense, very scalable networks, allow you to grow in areas where towers are facing each other. You could use much wider or lower gain horns in order to not be pointing at your other tower, and really gives you the flexibility to kind of put the coverage exactly where you need it to be. So all these things together create this massive scalability and meets the demand that you have for more clients and more throughput today. So all of our antennas are, built very well. We use non-corrosive metals like aluminum and stainless steel. We use UV resistant HDPE plastics and die-cast aluminum. So they're built very well with, again, all items that are non-corrosive for the harshest environments. Again, you can see more deployments that are out there, whether it's in the cold regions of Alaska and other areas, it's in the dry regions where there's deserts, or in dense cities and stuff like that. Our horns have been deployed all over the world. And again, you can see what your standard deployments look like for these really unique, high density, symmetrical horn antennas. So next, we'll move on to our Ultra Horn series. So this is the next TWISTPORT antenna in our symmetrical beam series of antennas. So the Ultra Horn is a much more narrow, higher gain horn, right? So the symmetrical horn, the Ultra Horn has a 15-degree wide beam angle, and it has 24 dBi of gain. So again, it's a highly precise beam. It's a symmetrical beam pattern like the other antennas that you have seen, again, with just more gain and more focus than the previous ones we spoke about. The Ultra Horn also has the same frequency stability that you've seen in the previous antenna pattern. So as the antenna sweeps through the frequency spectrum, again, it doesn't change as much as you change frequency, and therefore you get the same stability and same usability as the previous ones. Sorry, my animations here froze up. The same can be said for 0 side lobes on our Ultra Horns as well. So the parabolic dish antennas that most people use for point-to-point systems have, again, huge side lobes that create issues and therefore minimize the amount of throughput that you can push through your radio system when you have side lobes. Hold on a second. Yep, sorry, 1 second. Just give me a second here.
Sure, no problem. So we have a question panel on the right side of your webinar panel. And if you have any questions, please send us Jaciel Moran, our engineer for networking. He's helping us with that. And also Tassos will be answering all of your questions by the end of the webinar. So please.
Yes, and we see the questions that are already there, so we'll definitely get to those. So please stand by as we get to the end of the presentation.
Great, okay. Thank you, Tassos.
So we're back here. So for parabolic dish antennas, you see some simulations here of what we call the shroud effect, right? So on the left is your standard parabolic dish antenna. Typically, dish antennas are misunderstood to think that they have very high isolation, which they do have good isolation, but mainly because people look at the main beam, which is usually a very thin beam that comes out of the center of the antenna. But people often overlook the side lobes that are there. And you can see that actually a parabolic dish antenna isn't very narrow and small. It only looks that way if you don't pay attention to the side lobes. Here on the right, we're looking at that same exact antenna with a shroud put on it. A shroud is kind of that barrel round thing you put around the outside perimeter. And the shroud gives you kind of a, a feeling of more isolation, but what you can see is that it doesn't really make the side lobes go away. It just really pushes them forward and just moves them to a different place on the radio. So those side lobes still exist. If we look at it in 3 dimensions, without the shroud, you can see how the shroud simply just squishes those side lobes forward and creates even more and changing side lobes for the front to back of the antenna. So really, shroud antennas change the radiation pattern. So if you buy your antenna based on the spec sheet from that antenna manufacturer, and then you put a shroud on it, that antenna pattern no longer exists, and therefore you really don't know what you're getting. So true noise reduction comes from, again, antennas that are built properly from the beginning and are designed to not have side lobes. So on the left, you can see our ultra horn point-to-point antenna, which has a 15-degree beam angle compared to a parabolic dish antenna on the right, which on the spec sheet has an 11-degree beam angle, which is supposed to be much more narrow than our ultra horn. But when you look at all the side lobes that are putting out from that parabolic dish antenna, you can see that it's actually much wider than the ultra horn. So really the absence of side lobes is what gives you this great noise rejection and noise immunity. So pay attention to your radiation diagrams from the manufacturers of your antennas. Our ultra horn really has ultimate performance in all frequencies, in both polarities, across the entire usable spectrum. So typically you'll see parabolic dish antennas and you buy them because they have the highest gain. We'll say it's 29 dBi, right? Well, what you often don't know is that 29 dBi is usually at one specific frequency and sometimes in one of the 2 polarities, right? So our ultra horn and all of our horn antennas for that matter have very flat gain across the entire spectrum. So if you're moving from the upper UNI3 down to maybe a DFS channel, it's important to make sure that your antenna actually still has the same or close to the same gain as it had in the higher frequency regimes, right? So this is really important, and you typically don't see that with your traditional antenna systems out there. The ultra horn also makes antenna alignment really easy, right? Because there are no side lobes at that point, right? So it's hard to get those false connections where you might have too high of a gain of a dish at too short of a distance, and therefore your side lobe connections look high intensity enough, and you think it's a good one. With the ultra horn, you're either in or out of main beam connection. There are no false positives with the ultra horn. So very, very important thing. And it's something great if your installers are perhaps very new to the industry. It should definitely help them. We get the question a lot, is the ultra horn really a high performance antenna for point-to-point or point-to-multipoint? And really, the antenna doesn't care, right? The antenna doesn't care whether you use it for point-to-point or point-to-multipoint. What's important is, does the beam pattern fit your installation? If you have a high density of customers that are within an 8 or 10 or 15 degree beam pattern, then sure, you can use the ultra horn in point-to-multipoint, and a lot of WISPs are actually starting to use it when they need to increase their density, and a 30-degree horn is just too wide for the number of customers that they have. Then they split that 30 into two 15s using ultra horn. So again, multiple uses for the ultra horn. It's not just a point-to-point antenna. Again, like our previous antenna platform we looked at, the symmetrical horn antennas, our ultra horn is also built very well for the harshest environments, again, using all non-corrosive metals and very UV resistance HDPE plastics. If we look at some of the deployments here on the left and in the center, you can see extremely high density installs. These are ultra horns that are specifically used for point-to-multipoint. So again, a customer built out 180 degrees of coverage with, you can see here, 12 ultra horns, so pretty impressive. On the right, we see a 15 mile point-to-point with EPMP 1000, right? So this previous install, they had this EPMP 1000 as a redundant backup for a licensed link. It was only to provide 100 megs of throughput, again, as backup to a licensed link. It was using previously a 30 dBi dish, right? And this 24 dBi horn fixed the problems they had for thermal fade. So it went from, again, going down every morning as the sun came up and thermal fade started to rear its head, to now being so stable, this is over a year now, it's been up and running, that this went from a backup to full-time running VoIP over this particular link. So again, really shows you how well the antennas work and what's possible with them. So again, just some more deployment pictures here in point-to-point and point-to-multipoint. So now we'll move on to our ULTRADISH. This is our parabolic dish antenna based on our waveguide interface. So the ULTRADISH series comes in two different varieties. We have the ULTRADISH 550, which is a 550 millimeter dish antenna with 27.5 dBi of gain and a beam width of 8.5 degrees wide. The one on the right is our smaller ULTRADISH or ULD 400, which is again a 400 millimeter dish with 24.5 dBi of gain and an 11 degree beam angle. So as I mentioned earlier, when we see a lot of the antenna systems out there that have side lobes, you have to understand that the side lobes are inherent to those types of antenna systems. The same can be said for our ULTRADISH. The ULTRADISH is a parabolic dish, so all parabolic dishes have side lobes, but we're able to suppress some of those side lobes to give you a little bit more performance. So I just want to be clear so people understand that we're not saying our parabolic dish has zero side lobes. It has side lobes because it's inherent to that antenna platform, no matter who makes it, but we're able to suppress it and therefore give you some better noise immunity than possibly some other ones that are out there. One of the other focuses for when we built the ULTRADISH was not just to try and suppress the side lobes as much as we could, but was also to give you that stable gain. So again, if you look at the gain performance across the entire spectrum of operation for our ULTRADISH 400 and our ULTRADISH 550, you will notice that the gain is fairly flat, and it's fairly flat in both polarities. So we don't have two gain plots for a horizontal and vertical. We could use a single line because the gain is the same across the entire spectrum for both horizontal and vertical. So you don't see that high peak gain that you see with other competitors out there in one frequency and possibly only in one polarity. So this is really important when you're using these dishes as CPEs in high noise areas. So traditionally, people like using patch panel sectors or patch panel antennas for high density deployments. And you can see with all their side lobes, they're able to see your other access points, right, that are out there. With the ULTRADISH as a CPE, because of our suppressed side lobes, make it a much better CPE antenna in, again, very high noise environments and in very high density urban installs where you might have a lot of access points distributed throughout the city or on multiple microcells and stuff like that. So again, eliminating the side lobes or reducing them as much as possible in these high density, high noise areas. The ULTRADISH works very well for CPE or again in point-to-point as well. Our ULTRADISH series also has a very innovative mount like most of our antennas. You only really require 2 bolts. You mount the mount onto it and then the antenna slides and locks into place. Again, you can adjust the azimuth on the top and then eventually the elevation on the side here and makes it very easy to install. Makes it almost you know, a one-person install. You don't have all these nuts and bolts and washers on top of a tower or on top of a house that you can drop. So we've really made it in such a way to make your user experience for your installers much easier. So again, some deployments here you see for CPE and backhaul with both Mimosa and Ubiquiti here. So again, how you use it is really up to you, and it's very, very versatile. So now we'll move on to our asymmetrical beam pattern antennas here with our newest asymmetrical horns. Again, 3 different varieties. We have a 60, a 90, and a 30 degree, and we'll talk more about that in a little bit more detail. So again, if you haven't seen our asymmetrical horn series, you will notice now that the wider antenna patterns have more gain because we've changed the beam pattern shape of these asymmetrical horns. So the 90 degree asymmetrical horn now has 16 dBi of gain compared to our 9.5 dBi of gain of the symmetrical 90. The same for our 60 degree asymmetrical horn now has 17 dBi of gain compared to 13.5 of the symmetrical 60 degree horn. And then our 30 degree asymmetrical horn now has 20.5 dBi of gain compared to 18.5. So again, we were able to maximize gain, right? So again, the asymmetrical pattern is talking about its shape. So you can see how this one is 30 degrees wide and 20 degrees tall. We also have a beam shift feature, which you can rotate the antenna to make it 20 degrees wide or 30 degrees tall. Our 60 degree asymmetrical is 60 degrees wide and 25 degrees tall. And the same for our asymmetrical 90, it's 90 degrees wide and 25 degrees tall. So more of a sector feel in the beam shape of the antenna with, again, absolutely 0 side lobes and all the great performance we've mentioned with all of our other antennas. This beam switch feature is actually quite cool. So by default, the 30 degree asymmetrical horn is again 30 degrees wide and 20 degrees tall. But you can rotate the antenna with the mounting system 90 degrees. And now you'll end up having a 20 degree wide and 30 degree tall beam pattern. So if you need more density, if 12 30 degree APs isn't enough, maybe you need 18 20 degree wide beams, you can use the beam switch feature on the same antenna and therefore maximize your density and really increase the amount of aggregate throughput on your tower. So pretty unique and very cool feature of the asymmetrical 2030 antenna. You get a more perfect coverage pattern now, right? So again, you still get the small null zone, but you get more of the unique or the sector-like wider coverage at higher gain than you're used to. So again, for most of the lower density rural areas, these antennas work very well. Again, if we compare the Ultra Horn 60 to a patch array antenna, again, you can see there's no back radiation, there's absolutely zero side lobes, nothing but front-facing energy in a very precise and very uniform factor compared to your traditional sector. Again, you get that great frequency stability as you sweep through the entire spectrum. You can see that the coverage area doesn't change as much as traditional sectors do. So again, you'll have a much better user experience, and your customers will have a much better user experience as well. Something that took a lot of time, and we spent a lot of time in trying to make sure, was that we actually balanced both the horizontal and vertical beams. If you look at a traditional sector, typically your horizontal and vertical beam do not match, right? So you might have one polarity much wider than the other, and typically they take the average of those two beams and tell you that you have a 90-degree sector, when really horizontal is 110 and maybe vertical is 80, and the average comes out to something like 90. With our asymmetrical horns, we made sure that the vertical and horizontal perfectly overlapped, and therefore gave you the same coverage in both polarities, which is really important. And one of the reasons why you see all those MCS chain mismatches or the deltas between change on your traditional sectors. With our asymmetrical horns, you will not see it like you do with traditional sectors. So a very important part of what RF Elements brings to the table when we design antennas. So again, these asymmetrical horns are fantastic for rural deployments. This is now the answer for somebody who has a low user density of customers. You may need 360 degrees of coverage, but your business model really doesn't build out for 12 very narrow horns or something like that. So now you could use 4 90-degree asymmetrical horns or 6 60-degree asymmetrical horns to again address this lower density of users, and therefore still fit your budget. And again, without side lobes, you're still bringing all that noise immunity to the rural area, because no matter how rural you are, noise will find you eventually. So if you're not seeing it now, I guarantee you will see it soon, and might as well build from the beginning with proper antennas and therefore not have to deal with it later. So again, this is the perfect coverage for rural areas. We give you many different beam patterns. You have a 20, 30, right, a 60 and a 90, and you could also fill in with our symmetrical horns if you wish to still build out the coverage that you need based on where your customers are, and not send noise or hear noise from areas where you don't want to hear from. Again, like all of our antennas, we use all corrosive-free materials, metals, and plastics, so built very well for the harshest environments. So now we'll talk about our symmetrical horn series. This is the carrier class version of the symmetrical horns. Again, we won't go into great detail because the performance of the carrier class symmetrical horns are identical to what you saw with the TWISTPORT version. The only difference is that they have end connectors built into them. So why would you want to use these over the TWISTPORT version? Again, we spoke about earlier, maybe the radio platform that you're using isn't supported by a TWISTPORT. So there's no reason to buy a TWISTPORT antenna and then the connectorized TWISTPORT adapter if you know you're only going to use, let's say, the A5C from Mimosa, or the 450i series from Cambium, or again, any other radio manufacturer out there. This is convenient for you. It has end connectors built into it, so you get all the same antennas, all the same performance, just with end connectors built in. The same thing for our asymmetrical horn that we just recently spoke about. So again, if you're using any of those large form factor radios, there's no need to get the TWISTPORT horn and then the TWISTPORT adapter. Just buy the antenna with the end connectors built in, and then you won't have to worry about that second skew. We also support that in the Ultra horn as well. So we have the carrier class series of Ultra horn. Again, if you're using the PTP 550 from Cambium, or the B5C as point-to-point for your from Mimosa, again, the carrier class series of the Ultra horn would be ideal for you to not have to worry about, again, another adapter. So again, just some deployments out there. You can see in the early days on the right, before we had the TWISTPORT version of the EPMP 2000 radio, people used the carrier class because that was a, again, unsupported platform at the time. Here you can see people using the carrier class horns with Mimosa, extremely popular antenna system for Mimosa these days. Again, just use your LMR cable to the carrier class series of our horns and you're good to go. A new product that we have coming out now is our twin horn bracket, right? So this twin horn bracket will be available, supposed to be in February, but with everything going on now in China and around the world, some things are delayed in production. But the twin horn bracket is something you will see here in the near future. It makes for simple alignment of two horns. Very simple concept, right? So the twin horn bracket currently works only with our symmetrical series of antennas, and it has integrated radio mounts for the A5C from Mimosa and the EPMP 3000 from Cambium. So if you want to do 4x4, this makes it really easy for you to not have to worry about independently adjusting two of the horns with the same coverage area. So this again makes it easy to integrate the symmetrical series of horn antennas with either the EPMP 3000 from Cambium or the A5C from Mimosa at this time. So finally, now we'll move into the last antenna in our series, which is our carrier class sector. So our sector carrier class is our kind of legacy antenna system that we've had for a while. This is still a patch array sector. We have two different variants at the moment. We have the sector carrier class for 2.4 gigahertz, and it's 14 dBi of gain. And then we have a 5 gigahertz version that's 20 dBi of gain. So our, looks like the animation here, hold on. So our carrier class version, or our sector carrier class, has a back shield built into the antenna. So this is a very unique shield. It's not a third-party add-on. It's it's frequency selective surfaces that allow us to attenuate a lot of the back radiation and therefore also help us balance the beams in both horizontal and vertical. So earlier we had mentioned how your traditional sectors typically have unbalanced vertical and horizontal polarities. The carrier class sector from RF Elements has both vertical and horizontal beams balanced. You can see here some deployments out there. Again, the back of the antenna has the kind of uniform slip and lock into place adapter. So if you're using Ubiquiti radios and some Cambium radios, you can just click it and lock in place. You also have the pigtail cover to protect the pigtails that are built in there. So if you have the need for a patch array sector, we have both a 2.4 and a 5 gigahertz version available for those deployments. Oh, the slides are messing up again. I apologize. So at RF Elements, we're really, setting a new standard for networks. We're, creating antennas, our horn antennas with 0 side lobes and great noise immunity. Our TWISTPORT ecosystem allows for a more efficient transmission medium from the radio, therefore less loss to your antenna. And therefore we create or give you the ability for massive scalability on your networks to really build them out. Again, to recap, all of our antennas are built from, again, corrosive resistant materials, aluminum, stainless steel, zinc, and UV rated plastics. One important thing to note is that our stainless steel hardware, like any stainless steel hardware, requires the use of anti-seize lubricant. So if you use our antennas, please use anti-seize on all the bolts to mitigate the scalding that happens with stainless steel. Right here as we get to the end, I apologize for this as well. Hold on. Let's try this again here. Sorry. So a great place to get information is really on our YouTube channel. For those of you who have not been there, we have a lot of great material on our YouTube channel. So we have great customer testimonials. We have a video series called WISP Traveler, where we've traveled the world and we visited many WISPs, and they told their stories of how our products has helped their WISP and helped their business to increase. So again, it's one thing to sit here and listen to the manufacturer tell you how their product works. It's best if you hear it from your fellow WISP. Chances are some of these WISPs are dealing with some of the issues you might have right now. So it's a great way to learn how they help mitigate those issues. We also have a new series called Inside Wireless, for those of you who haven't seen it, which is a educational video series we put together to really demystify and explain RF, which is, black magic to a lot of people, right? So it's a great video series for yourself. Maybe if you have new employees that don't understand wireless very well, it tells them, explains what gain is, what side lobes are, front to back ratio, all these different terminologies that are used in wireless today. So it's a great resource to get some information on the industry and how RF works. Our online community. So we have a pretty active forum. It's rfelab.com. Again, a great place to come to and talk to other WISPs that are out there. Again, maybe you're having a problem, you can search our forum to see how that problem was solved, or interact with us and ask us questions directly. So with that, here's our trademark disclaimers, and letting everybody know that the third-party trademarks are used solely to reference the compatibility of those products with RF Element products, and all rights of respective trademarks owners are reserved. So with that, we'll go to the question and answer. So I don't know if you want to hop in here real quick and say something, or should I just start going through the questions that are asked?
Thank you, Tassos. Well, we already have a few questions. If you can start with those, and if someone wants to talk or send us a brief audio, we can open your mic and then you can talk directly to Tassos. But then also we have the questions, the question panel. But yeah, that will be great if anyone wants to do that.
Yeah, so that'll be great, and I'll go through these questions first that we already have in here, and then we can open up the mic. That would be fantastic. So the first question I have is dual slant config. Does it work for the ULTRADISH TWISTPORT series? So again, any of our symmetrical antennas support dual slant, right, as a function of the antenna. The problem there comes with the adapter itself. So all of our adapters are vertically and horizontally polarized, right? So that's the first part of it. As you may have seen in the beginning when we went through our TWISTPORT adapters, the C5X adapter for Mimosa actually supports the ability to switch between H and V and dual slant. So if you're using the C5X, with that adapter, it will be 100% supported with that antenna. Let's see, next question here. So somebody's asking about the GPS antenna for Cambium EPMP 2000 and or 3000 can be installed inside the adapter like Ubiquiti one. So unfortunately, no. The reason for that at the moment is that, again, if you look at the Ubiquiti radios, the GPS connector is at the top with the RF connector. So when you slide it into the TWISTPORT adapter, we have access to it. For the Cambium radios, the GPS puck is the GPS connector, unfortunately, is at the bottom, right? So it doesn't allow us to slide it in there. I suppose later on, perhaps we can do something, but currently, no, the GPS antenna is not supported inside of the adapter like the Ubiquiti. Another question here is, do we plan to release ultra horn with more gain for longer distances? So we get this question a lot. You know, we're constantly 3 or 4 steps ahead with our technology. So I can say we're certainly, when we can do it without or possibly not having the antenna be extremely massive, we might, because there's a relationship between the size of the antenna and the gain of the antenna. And just to understand, for every 3 dBi of gain, you have to double the volume. So if you can imagine, an ultra horn at 27 dBi of gain would be quite massive. So we're currently looking into it. If we can do it in a form factor that's still usable, I'm sure we will, right? So we're always looking for that. Somebody asked if we will send a transcript of this. Yes, that will be online, the video as well. Somebody asked how to know when to use symmetrical versus asymmetrical, right? So we actually have a link calculator on our website, which is a great resource. Really, whether you use asymmetrical or symmetrical depends on what you're trying to build, right? And there are many different horns that we have available to kind of fill in the little nooks and crannies. So, you know, if you're, you know, as a general rule, if you're trying to build, you know, very high density, then you probably want to use, you know, the 30 or 20 degree symmetrical or asymmetrical is fine. It's more about beam angle and gain versus asymmetrical or symmetrical. So if you need the distance and you need a wide azimuth, then asymmetrical is probably for you in a more lower density deployment. If you don't need the range, but you also don't have the density, the symmetrical 90 degree might work for you. Again, the true answer comes from when we have all the variables, we put it into the link calculator, and that's really where you get your answer. So you have to kind of test between those two. Unfortunately, there is no basic guideline for the simple way to know which is which. You can always ask us as well. I do that personally every day. So WISP, come to me. You can email me or ping me on Facebook, and I can help you answer that question by going through, you know, all the variables that we need in order to make the proper decision. Okay. Next question here is, In the picture of a deployment of the ultra horn carrier class, I've noticed special jumper cables with corrugated protection sealed. Yeah, so again, in some areas of the world, specifically, we see this a lot in Australia and even in New Zealand, where and in some tropical areas where they have birds with very sharp beaks. They like to eat the LMR cable. So that corrugated, what they do is they run their LMR in an outer shield, right? So they put an, either another plastic or a braided metal shield around it to protect them. I don't know where they really get it. It's not an accessory of ours. That's something that they came up with. And again, I'm sure you could probably ask on Facebook or other social media or even on our forum where they source those materials if you feel or you think you need them. I got a couple more questions here, and then we can go to opening up the mic if people want to talk live. I'm happy with that. In the traditional sector, we showed like a star mount for 6 antennas. Do you have this mount or accessory? Again, that's not an accessory that we make. I forgot off the top of my head who actually makes it. Again, I think if you go on our forum, I believe it's there. We can look it up. If not, you can ask the question, and somebody I'm sure will be happy to. Do you have software to make path calculations? So again, I mentioned if you go to rfelements.com, you could use our link calculator, and we can show you both point-to-point and point-to-multi-point link calculations. And then finally, somebody needs some more information. We can go ahead and email you and open up a dialogue if you wish. So that's the last of the questions that are in the question queue. If you want to take over now and see if anybody wants to ask questions live, I'm happy to do those as well.
Thank you, Tassos. If anyone wants to talk about a new project that you guys might need any help, or you just want to shoot out a few questions, please raise your hand on your panel, and that way we can know that you're ready to open your mic. Or if you want to do it over the question panel, let us know that you're ready, and then we can open it.
So I'll finish with this last slide.
I think
nobody has
Jose Luis Bravo, Tassos, let me try to open his mic. Jose Luis, we're gonna open your mic. Thank you so much, and let us know. You're live.
Okay, can I speak Spanish?
I think we can translate that for Tassos.
You can translate it for me, no problem.
Yeah, totally.
Okay, nosotros estamos usando la RF element segunda generación de 60 grados, pero aún así tenemos mucho ruido y la distancia es muy corta para lo que nosotros utilizamos, que son unas 3 o 4 millas. ¿Qué solución me recomiendan en ese caso? Porque la estamos usando y todavía no tenemos el rendimiento que queremos.
Okay, Tassos. So Jose Luis, he's using the 2nd generation, the 60-degree antenna, but he's having a lot of noise, and the distance is not that far. So he's using it for 3 or 4 miles, and he's having issues with that. What will be a solution for that?
So, sorry, which is he using, the symmetrical or asymmetrical 60?
Jose Luis, which one? ¿Cuál está usando? ¿La simétrica o asimétrica?
La simétrica, y también tenemos las carrier class de RF element, las que traen la de shelving, también tenemos de esa, y las estamos mudando a simétrica para buscar una mejoría, pero todavía no tenemos los resultados que queremos.
Okay. So those 2 antennas, Tassos, I don't know if you heard which one.
I heard that it was a symmetrical 60.
Yeah.
Okay. So it kind of depends on which radio platform you're using as well. One of the things, if you're seeing noise, you can try. I'd have to do the link calculation to see, based on the CPE and the what CPE he's using at those distances, how far the link can actually go with the 60, right? So the symmetrical 60-degree horn has 13.5 dBi of gain. If the noise is coming in from the horizon, because the antennas, or actually I should say, no antenna can filter the noise that comes into the front of it, right? It has to be open. We get no isolation out the front. What we can do is you start to utilize down tilt to make it more deaf at the horizon, right? So if we can contact with him later, we can do the link calculation to see how much gain he really needs. The 60-degree might allow for down tilt to make it less gain at the horizon while still allowing enough gain for his customers to have the signal. The only other choice that we have is perhaps taking that 60-degree and cutting it in half by utilizing two 30-degree horns instead. So again, there's a few different things. I don't know if you can remember to translate that, but the core of the message is down tilt helps fight the noise that's coming in the front, right? The other thing we can do is we can split that wider horn into more narrow to help fight noise. And then the third one would be radio dependent, right? Some radios have active filtering built into them, right? Like the PRISM and stuff from Ubiquiti. So perhaps another radio might work better in that situation.
Thank you, Tassos. So I'll be sending this information to Jose Luis. And also, if anyone needs any information about their project that you're already working with, you can send us your coordinates and the information about the radios that you're using. That way we can send that information to Tassos and Hesiel, and they can help you directly to calculate the link. So we'll be sending you the information, and into that email, you can reply back with all of your coordinates. So now I'm going back with Mario Mazariegos. So we're gonna open your mic, Mario. Hello, Mario, you're live. Hello, Mario. I think I'm gonna unmute him. Well, now I'm gonna go with Fernando Yanez. Fernando, we're gonna open your mic if you got any questions. Hello, Fernando. I think his mic is off, Fernando. Or Mario. I'm opening both mics.
I only see Mario's open. I don't see Fernando's open.
Yeah, I think. Hello, Fernando. Now we're hearing you.
Good morning. Can you hear me?
Yes.
Okay. Can you speak Spanish or you prefer English?
Yeah, you can speak Spanish and we can translate to Tassos.
Okay. La pregunta era si existe tal vez algún software que ustedes tengan para poder hacer los cálculos de acuerdo a los diferentes tipos de adaptadores que tienen.
Okay. Tassos, so the question is about the software. So I don't know if on the software to calculate the links, there is a way to actually include what CPE or what radio we're using.
Yeah.
So add that calculations. Awesome.
Yeah, no, it is, right? So the only variable that we need from the CPE is the gain of the antenna. So when you're in the point-to-point or point-to-multi-point, you will see a section in the link calculator. And actually, I can bring it up since I'm sharing the screen. Just
awesome.
Let me just do that real quick here. So this is our link calculator. Can you see it come up?
Yes.
So I can just give you a quick demo here, right? So you can actually drop the pins and put them wherever your link is. Here, from the drop down, you pick whichever antenna it is that you want to do the link for or you want to use. Here is where you adjust the TX power that you put into the radio, right? So whether it's 20 dBi, 15 dBi, or potentially 25, dBm of TX power, you drop that into the calculator. Here you can adjust the down tilt to see how much down tilt you might need or you could afford. Here is the slider for your radio platform. So you have to know which radio you're using. If it's a PRISM or EPMP 3000, it supports up to MCS 9. If it's AirFiber 5, you set it to MCS 10, which is the maximum rate. And then finally here, to answer his specific question, here's the CPE setting. So all we need to know is the gain. So if he's using, let's say our ULTRADISH 400, he would put 24 dBi of gain there. If he's using the Power Beam or the Force 300 from Cambium, I believe that's roughly 25 dBi of gain. So simply just put the gain of the CPE there, and then it will adjust everything for you based on those settings. So I think that should answer it. Yeah, so if somebody's saying Cambium is 27, so again, you would just put 27 dBi of gain here. Oh, I lost my calc page here. It's also in Spanish as well. So if you click the Espanol key here, it will translate everything for you as well. So I think that should answer it. Also, we have some tutorials in English on how to use, again, the point-to-point and point-to-multipoint function in Spanish. So you can go ahead and watch these two videos. Is probably better than me explaining it in English.
Thank you so much, Tassos. Okay, so I think we're ready. Thank you, Fernando. I think we're ready for this session. We'll be coming up with more webinars in the following days. So please be checking your email and our AppCom website so you can register for future webinars with Tassos and RF Elements. Well, I think it will be everything for today. We'll be sending this presentation as well as the recording of the webinar to your email. And please send us any questions that you might have with all of your coordinates, the CPE that you're using, all the information, so Jaciel and Tassos can help you right away. Thank you everyone for being, go ahead, Tassos.
Yeah, that's right. And if I could add, we also have a Spanish-speaking support person on staff as well. So please don't be worried about sending it in Spanish. You'll either speak to me if you're comfortable in English, or Jorge, we can put you with our Spanish-speaking person as well. So we got you covered in both languages, no problem.
Yes, Pedro Ramirez, he is part of the RF Elements team. So he's the channel account manager for North and Latin America. So he will be also helping us if you guys have any issue with the English section. He can help us in Spanish too.
Great. Thank you everybody for joining.
Thank you, Tassos. Thank you so much for your great webinar. Thank you, Jaciel, for helping us with all of your questions, and hope to see you pretty soon on our AppCom webinars. Thank you, and be safe out there. Thank you. Have a good one. Bye-bye.
Bye.